Hello. Today we're going to talk about passive transport. So, transport means transport describes any time that materials are moving into or out of a cell. There are two ways that transport can happen, with and without energy. Transport with energy is called active transport. If it requires energy, active. Transport without energy is called passive transport. That's what we're going to focus on today. Have you ever experienced maybe a parent sprays some air freshener in one end of the living room and then you can smell it by you? Or maybe someone sprays on a lot of perfume or body spray and then even if you're not standing next to them, all of a sudden you can smell it? What happens? Those scent particles are going to spread out across the room until everybody can smell them. This is actually a form of passive transport called diffusion. Here's an activity that you can try at home. Take a cup of water and put 1 drop of food coloring into it. Over time, the food coloring is going to spread out until the entire cup is the same color as the food coloring. And this will happen whether you stir it or not. This is just like the scent. We can picture this little drop of food coloring is like spraying the bottle, and then it slowly spreads out over time. This is what we're talking about when we say passive transport. Things just spread out over time without any energy. So, passive transport is when materials move without energy. They're always moving from an area of high concentration to an area of low concentration. So when you spray the air freshener, the high concentration is right by the air freshener bottle, and the low concentration is far away. Or if you look at this diagram, all the particles gathered together would be a high concentration, and then they're slowly spreading out to where there's a low concentration. If there is a really crowded room, that could be a lot of people, and people naturally kind of like to spread out and be in a lower area. At least if you're introverted, you do. And we're going to talk about 3 different types of passive transport: diffusion, facilitated diffusion, and osmosis. So diffusion is what we've already been talking about. It's when particles move from an area of high concentration to low concentration. This is the cell membrane, and this is the area of high concentration, and this is the area of low concentration. These particles are naturally going to move in and out of the cell membrane. Notice that they are going in both directions, but over time, it's going to reach equilibrium, which means there's an equal amount of particles outside and inside of the cell. They will still tend to move back and forth, but they'll continue to balance themselves out. So this is a drawing of the particles of what happened when we sprayed the air freshener or mixed the food coloring with the water. So here's a diagram, and here's what we just talked about. This is another artist's view of the cell membrane, and here's diffusion, when particles go from an area of high concentration to an area of low concentration. And notice how they're able to move directly through the cell membrane. So small, nonpolar particles can diffuse directly through the cell membrane. But what if there was something that's bigger or polar? Then it can't go through the cell membrane because the phospholipids keep it out. It's going to go through a protein. That's called facilitated diffusion. Facilitate means to help. So the protein helps the particle be able to pass through the cell membrane. Notice we're still going from high to low, so it's still passive transport, no energy, but it's facilitated diffusion because it's going through a protein. And osmosis. Osmosis is a specialized type of facilitated diffusion. So that means that there is a protein in the cell membrane, and it's specialized because it only applies to water. And the protein that lets water through is called an aquaporin. Still going from high to low, no energy. I'm going to talk about a few applications of osmosis now. A cell is influenced by its environment. If there's a concentration gradient between the inside and outside of a cell, it causes water to move. The net movement of water out of or into a cell produces a force known as osmotic pressure. So to say that simply, if you take a cell and you put it into like a salty environment, that's actually going to force water to move. Like that high concentration of salt is going to force osmosis to occur. We're going to talk about specific forms of osmosis now. Isotonic, hypertonic, and hypotonic. So here is my cute little cell. The Mickey Mouse head represents water molecules, and I decided to draw the salt as triangles. That's not really what they look like. It's just easy for me to draw. And notice that we have like 4 water molecules in the cell and 4 salt molecules inside of the cell. Now we're going to put that cell into a beaker. And notice the beaker also contains like 4 water molecules and 4 salt molecules. So we pretty much have the same concentration inside and out of the cell. Let's take a look at what kind of osmotic pressure that causes. There's the same concentration of salt inside the cell and the beaker. Water will flow into and out of the cell without any net change. This is described as isotonic. We can say the cell is isotonic to the beaker. Iso means same. We can also say the beaker is isotonic to the cell. So isotonic is a fancy way of saying the concentration is the same. And you always have to say what you're talking about. Like you have to give a point that something's relative to. Like we're comparing the cell to the beaker, or we're comparing the beaker to the cell. Another example. So here's our same cell, but this time we're putting it in a different environment. Notice there's a high concentration of salt in the beaker. So there is more salt outside of the cell. This will cause water to flow out. That's that osmotic pressure we mentioned earlier. If all the water flows out of the cell itself is going to shrink. The cell has less salt than the beaker. So we would describe the cell as being hypotonic when compared to the beaker. Hypo means less. The beaker has more salt than the cell. The beaker is hypertonic compared to the cell. Hyper means more. Another example, same cell again, putting it into a different environment. This time, the high concentration of salt is inside the cell. So this time, there's more salt inside of the cell. This will cause water to flow in. And if water flows into the cell, it can cause the cell to expand. The cell has more salt than the beaker. So we can say the cell is hypertonic compared to the beaker. The beaker has less salt than the cell. The beaker is hypotonic compared to the cell. Don't feel bad if this is confusing. We're going to go through a few examples and hopefully you'll start to feel better. So here is a summary of those 3 conditions that we just did and the way that the water will move. This first one, as a review, the cell is isotonic to the outside. That middle one, where there's a higher concentration inside, so water flows in, because there's a higher concentration inside, we can say the cell is hypertonic to the outside. And the last one, there is a lower concentration inside the cell, so the cell is hypotonic to the outside. Remember that about this one, I could also say the beaker is hypotonic, and then for this one, I could say the beaker is hypertonic. So we can't ever just label it like, oh, it's hypo or oh, it's hyper. We always have to explain like what we're comparing it to. Let's take a look at this picture again. And if you notice, like just looking at that arrow, it kind of looks like the water is moving against its concentration gradient. Like it kind of looks like it's going from an area of low water to an area of high water. That's because I just didn't draw the water molecules on here. If I did, this is what it would look like. So in reality, wherever there is a like lower concentration of salt, there's going to be a higher concentration of water. So where water will always move to wherever there's more like salt or sugar or whatever. But when water does that, it's moving from a high water concentration to a low water concentration. I tried to draw it on here. So water will move to wherever there's a high salt, But just remember, water is going down its concentration gradient from high to low. That's what qualifies it as passive transport. Or in this scenario, there is a higher concentration of salt outside the cell, which means there's a lower concentration of water outside the cell. So passive transport, water flows down its concentration gradient. All right, new example. This time we're going to work with sugar and water. So go ahead and take a minute and pause the video and write out some descriptions for this container. First thing that I did to help me out was to add the water molecules. So I noticed that there was a lower concentration of sugar inside the cell, so that told me there'd be more water. And the exact opposite, because there's a higher concentration of sugar in the beaker, there would be less water. Because there's more sugar outside of the cell, water is going to flow out. And this can cause the cell to shrink. Because the cell has less sugar than the beaker, the cell is hypotonic compared to the beaker. The beaker has more sugar than the cell. The beaker is hypertonic compared to the cell. Here's another example. That is my drawing of a blood vessel, like an artery or vein, and those are little red blood cells floating in the plasma, the liquid part of your blood. And this time I've added some potassium to represent the little dots in there are potassium. And notice there's a higher concentration inside of your red blood cells. So again, pause the video, take a minute to write down what's going to happen. Hopefully you came up with this. There's more potassium inside of the cell. Therefore, water will flow in, and that can actually cause the cell to expand. We can also say that because the cell has more potassium, the cell is hypertonic compared to the vessel. Or because the vessel has less potassium, the vessel is hypotonic compared to the cell. Funny thing, or not funny thing that can happen, if your blood cells actually take in too much water, it can cause them to burst and then you can die. When people were first getting IVs, if people, like an IV is like a sack of like basically salt and potassium and water that the hospitals will give to people who are dehydrated. If they put the wrong concentration in there, it can create a hypertonic solution and then your cells burst and then you die. So this used to be a problem, and now hospitals take your weight and figure it out a lot more accurately. And that's it. So if you feel confused, that's normal. Come back, try to learn it again, use other resources, and email me whatever questions you have. Thanks.